Welcome to Hartman Math. This is lesson 611, where we're going to be graphing the sine function. So before we get to that, just looking at a part of our unit circle, quadrant number 1, where we're going from 0 degrees to 90 degrees. So maybe let's fill in the other key angles on the unit circle in degrees. 30 degrees. 45 degrees. 60 degrees. And then coordinates, straight right, 1 unit, 1, 0. 30 degrees, so kind of thinking of a 30, 60, 90 right here, long and short. Long would be square root of 3 over 2, comma, short, 1/2. 45, 45, 90, the legs are the same, so that's the root 2 over 2, comma, root 2 over 2. 60 degrees short and then long, so basically the reverse of 30 degrees. And 90 degrees straight up, 0, 1. And then these just kind of continue. The next one would be 120, where this moves over. X would be negative, Y still positive. We went left and up. And since we're focusing on the sine function, we're going to be talking about the Y coordinate, 0, 1/2, root 2 over 2, and so on. So we're going to need some graph paper. And so we're going to have a very long here x-axis. We really need 24 spaces out, because what we're going to do in labeling our scale going this way is every 15 degrees is going to be a mark, essentially. So 15. So we're going to kind of skip over a few. So every 2 marks, we're going to say, well, if every mark is 15 degrees, every 2 marks is going to be 30 degrees. We're going to set it up that way. We're going to have 1 be 4 spaces up, and that means -1 is 4 spaces down, setting up our vertical scale. We said 2 spaces is going to be 30 degrees, another 2 is another 30 degrees, or 60, 90, keep adding 30 degrees every 2 spaces. Keeps going. 300, 330 degrees, 360 degrees. So we've gone once around the unit circle. We're going to evaluate the sine function. So if we go back for a second, or you look at your paper plate, or whatever, we're saying we're going to start here at 0, x, substitute f of 0, sine of 0. We're going to look for the y coordinate by evaluating the sine of 0. Well, the y coordinate at 0 degrees is 0, so we would have a point at 0, 0. The next key angle for us is 30 degrees. And the sine of 30 degrees is the y coordinate at 30 degrees, which is 1/2. So if 1 is 4 spaces up, 1/2 would be half of that, 2 spaces up. At 30 degrees, we are 2 spaces up, representing a value of 1/2. The next key angle is not 60 degrees, but it's actually halfway in between here. It's 45 degrees. And the sine of 45 degrees is the y coordinate. It is square root of 2 over 2. If we approximate that on a calculator for the purposes of locating where it would approximately be on the graph, if you type that in on a calculator, the square root of 2 divided by 2, you're going to get about 0.7. So each of these spaces is 1/4, or 0.25. So not quite all the way up to the third space, just a little bit below the third space is where we have that. So just a little below, so it's not centered on that. All right, the next one is 60 degrees. The sine of 60 degrees is the square root of 3 over 2, because that's the y coordinate. Once again, if we try to approximate that, type that in on a calculator, square root of 3 divided by 2, we get about 0.87. So it's pretty close to halfway between the third and the fourth mark. 90 degrees, the sine of 90 degrees is 1. That's the y coordinate, so we're going to put a point at 1. There's that 90 degrees right there. The next key angle is 120 degrees as we move into quadrant number 2. Well, the y-coordinates in quadrant 2 are the same as they would have been in quadrant number 1 because we're still going up, so they're still going to be positive. So when we get to 120 degrees, which is 60 degrees away from 180, it's going to have the same value as 60 degrees here. Square root of 3 over 2, about 0.87. And then 135 degrees right here is going to match up with that one, square root of 2 over 2. 150 degrees, the sine of 150 degrees is 1/2. And then we jump to 180 degrees is our next key angle, the sine of 180 degrees straight left. The y-coordinate is 0, we are at 0. We continue. Quadrant number 3. Well, in quadrant number 3, we're going left and down, so our y-coordinates are going to be negative. 210 degrees is 30 degrees past 180. So kind of the same value as we had here, but negative, so negative 1/2. That's the y-coordinate at 210 degrees on the unit circle. And then continuing the pattern, 225 degrees, negative square root 2 over 2, about negative 0.7. Sine of 240 degrees, negative square root 3 over 2, about negative 0.87. And 270 degrees is negative 1. Jump to 300 degrees, quadrant number 4 now, going right and down, so still down, y-coordinate still negative, we follow the pattern. Oops, skipped one there. There, and then we finish 360, sine of 360 degrees, back where we were here at 0 degrees. They're in the same location, so also 0. So these are our points. We would fit a nice smooth curve through those points. So you can kind of see that it's resembling a wave. The sine curve is a wave. It's very rounded, soft and curved. And this represents one full period. The period is, we're going to see in a moment, is the distance that it takes to complete one full cycle. We've got an up cycle, we've got a down cycle. So that is the sine function. Now when we graph the sine function every time, we don't need all these points. We're going to go with key points. And the key points occur at our quadrant angles, 0 degrees, 90 degrees, straight to the right, 180 degrees, 270 degrees straight down, back to 360 degrees straight to the right. So we kind of understand the pattern at those quadrant angles. Starts at 0, then goes to positive 1, back to 0, down to negative 1, back to 0. That's the pattern. 0, up to maximum, back to equilibrium, down to minimum, back to equilibrium. So before we move on to other sine graphs that we might need to do some transformations on that, let's get to kind of some of the basics here about that sine function, some of the things that we've discussed in relation to other functions as well. Now, we did say this is one full period. We just looked between 0 and 360 degrees, but we've seen in other places that we can go negative. We can continue, and the graph kind of continues. It's going to keep doing this wave thing to the left, and it's going to do the same thing. It's going to keep doing this wave thing. It doesn't go up forever. It's just going to continue to wave just like this. To the left, to the right, it's going to keep doing the same pattern. But we're just going to focus on from 0 to 360 degrees. But based on that, what is the domain of our function? It goes left forever. It goes right forever. It's negative infinity to positive infinity. The range is a little trickier, not too bad. Remember, range is how low to how high. This does not go down forever. It just keeps doing this bouncing thing. So we say, well, how low does the graph go? Right there. That's how low it goes, -1. How high does it go? That's the highest point, +1. Everything is between -1 and +1. So our range is bracket, because it does touch those points, -1, +1. Where is our graph positive? Where is it above? Here. This is where we're above, starting at 0, ending at 180, not on 0 or 180, so we would use parentheses there. Where is it negative? Where are we below? This is the section that's below, from 180 to 360. When we say this, we're really just referring to this part of the graph, because as it continues, there's other places where it's going to be positive and negative. We're just focusing on this one primary, we call it period, of the graph. Where is it increasing? Where does our graph start to go up? And if we ignore that, again, we focus on just our standard period here. It starts going up here. Where does it stop going up? Oh, right there is where it reaches its maximum, so it stops going up there. So 0 to 90. Is there any other place where it goes up? I think so. Starting here, it's going to go up. Starting at 270, ending at 360. We didn't talk about it here, but we could also identify maximum. Where is there a maximum? There is a maximum of 1 at x equals 90 degrees. And then because right here we changed from decreasing to increasing, there's a minimum of -1 at x equals 270 degrees. All right, decreasing. Where is the graph going down? Well, it starts to go down. It's down, 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 down. Keeps going down all the way down, 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 down. So started there, ended going down here from 90 to 270 degrees is where we're decreasing. Example number 1, we're going to graph f of x sine of x. We've already graphed that. We're going to graph it faster. We're going to label our axes with the quadrant angles. So first one is going to be 0 degrees, and then we go straight up 90 degrees. Then another 90 takes us to 180. Just the quadrant angles is what we're going to use as our key points. So just labeling the quadrant angles. Remember that sine of 0 is 0. So sine starts typically on the x-axis as our first key point. And then since the sine of 90 degrees is 1, it starts by going up, reaching its maximum here. And then we return back to the x-axis. Now we continue below the x-axis to its minimum value at -1, and then returns back to the x-axis. Good way to get the correct shape, you know I care about shape, just kind of think of between these three here, just kind of think of a parabola shape. That's the shape that we want, and then a separate parabola shape connecting those, so that we get the correct shape. We don't want this to bend like this. I've seen it before. It doesn't bend like that. It bends in this section concave down. All right. Well, the period, definition-wise, the period of the sine curve is just the length or distance of one cycle. We create a up and a down. So it starts here, ends here. We went from 0 degrees to 360 degrees. That's the distance of 360 degrees. For our purposes, in this course, we're not going to be changing the period. So it's always going to be 0 degree, a period of 360 degrees. There are different things we could do to the sine function to change the period. Might have to wait to math 3 to see that. All right, so the midline is the line that would cut our sine function in half, where half of it's above it and half of it's below it. And if we haven't made any transformations, then it's going to be the x-axis. When we think of the x-axis, this half's above, this half's below. The x-axis cuts our graph in half. The equation of the x-axis, being a horizontal line passing through 0, is y equals 0. Amplitudinal vocabulary. The amplitude of the sine curve is the distance from that midline, for us right now, the x-axis, to the highest or lowest, but let's focus on the highest point. So how far is it from the x-axis to the highest point? That distance is 1. So for our base sine function, the amplitude is 1. Example number 2. G of x equals 2 sine of x, period. As I've said, I'm not going to change it. 360 degrees. Let's label 90 degrees are quadrant angles, 180, 270, 360 degrees, period. 360 degrees. Sine starts at 0, 0, because the sine of 0 is 0. 0 times 2 is still 0. Now at 90 degrees, the sine of 90 degrees is 1, because the y-coordinate at 90 degrees is 1. Multiplied by 2 is now 2. So we've taken our max point here and we've stretched it vertically by a factor of 2. So now it's at 2. That's where that highest point is going to be. And then we go back to the x-axis. We were on the x-axis, above it, back to the x-axis. Kind of keep the pattern going. We're going to go below it, 2 below it. Stretch by 2. So 2 below it, we can kind of verify that by saying that the sine of 270 degrees is the y-coordinate. It's -1 times 2 is now -2. And then we're back to the x-axis. So carefully, parabola shape, draw the curve. The midline is still the x-axis, cutting us in half. So y equals 0 for the midline. Amplitude, what's the distance from the midline to the highest point? Midline, highest point. That distance is now 2, known as 2. Amplitude is 2. All right, your turn. Go ahead, pause here for a moment, kind of look through, get the graph, make sure we label scale on the x-axis, identify your period, your midline, and your amplitude, and play when you're ready. All right, let's label our scale, 90 degrees, 180 degrees, 270 degrees, 360 degrees. We know that our period is going to be starting, finishing 360 degrees. Sine starts on the x-axis. Technically, it's really going to start on the midline. That's what's going to happen. Then sine of 90 degrees is 1, but multiplied by -3 is now -3. So the negative has caused us not to start by going up like sine normally does, but it's caused us to go down 3 away, 3 below the midline, So we're going to have a point down here at 90 degrees, comma, -3. Then we're back to the midline. Then we're above by 3. And then we're back to the midline. Careful on your shape as it got stretched out and reflected, the negative reflected, which is why we went low first. Here's our graph. Our midline, still the x-axis, y equals 0. The amplitude, the distance, what's the distance from the midline to the highest point? Distance is 3. -3 is not a distance. The distance is 3. Amplitude is always positive because it is a distance. The amplitude is 3. Example number 3, graph S of x is equal to 2 times the sine of x minus 1. Let's label our scale. Period, it's complete 360 degrees. Let's go ahead and talk about the midline. Think about this. What kind of transformations do we have going on here? We have two transformations. As we just saw previously, we have a vertical stretch, but we also saw that that does not affect the midline. What is this doing to the graph? In previous graphs, this means we're going to shift down 1. That affects the midline. If we're shifting down 1, the midline's going to go down 1. So the midline's now going to be y equals -1 as it went down 1. Let's draw that in. Now let's get the shape. The sine graph for the base graph starts on the x-axis, but really the sine graph starts on the midline. So at 0, we are on the midline. And then with a, or a value, stretch, being positive, we're going to start by going up. The next key point, we're going to be above. How far above? 2 above. So here we're going to be 2 above the midline. And the next key point returns back to the midline. And then we go below the midline. How far below? 2 below. And then we return to the midline. So again, the pattern was on the midline, above, back to it, below, back to it. Draw the shape. What is our amplitude? The distance from midline to highest point is 2. Your turn. Pause here. Graph R of x. Identify period, midline, amplitude. Give it a go. Hit play when you're ready. Let's label our axis. We know our period. The midline, we're going to shift this graph up to midline. Goes up to the midline is now going to be y equals 2. Let's draw that. Sine graph starts on the midline. Then we're going to go, well, we got a negative here. In front as an a value is actually -1. So we're not going to start heading up like we normally do. Reflection. We're going to start by going down, down. How far below the midline? 1 below. As we know, this means -1. So 1 below the midline is at our next key point, 90 degrees. Then we're back to the midline. We continue the other way, 1 above the midline, back to the midline. Parabola, shape, to get the correct shape for our wave, our amplitude, distance from midline to highest point, 1. All right, last last one, we've got an existing sine function graph, and we need to come up with the equation, the function in this form for that graph. So I would start by thinking, well, what's the midline? What line cuts it in half? Could we graph it? Could we draw it? There it is right there. That's the line that's going to cut the graph in half, half below, half above. The midline is your D. It's up 1. It's positive 1. Now the A is going to be positive if we're going up to start, negative if we're going down, so it's going to be negative. And then how far below the midline is that point or this one above? What's that distance? It's a half. So A is negative because we went down first, a half because it's a half below the midline. There's our function. Probably should say f of x is equal to negative 1/2 because it went down, half below, sine x plus 1. This is the midline right there. And that's it for today. See you next time.